Good morning, my dear children. Already we are finished physics first chapter. Now we are going to physics second chapter, motion. Okay, we have to know what is mean by motion. Example: a person is standing. He is at rest. When he moves one place to another place, look my fingers. A person is moving. Assume that a person is moving. This is known as motion. When a person is stay in a place, that is known as rest. Example: mangoes in a mango tree. Mango on the tree, that is rest. When it is fall down, that is known as motion. Motion means what? No, a object is moving one place to another place. That is known as motion. Look at the starting page number. This is motion. There, look, some few boys are playing football. That is going on motion. Football is motion. Sir, there is two child, a student and sir is talking. Sir, how fast does the soaring of plane fly out of sight? Look, aeroplane is moving. How much speed is moving? Making that sound now. There is nothing so surprised about it. Aren't we two moving at a great speed? A object moving great speed, great motion. A object is slow moving, slow motion. About the speed, depending the speed, we can tell the motion, how much is more, how much is less. Next look, page number 76, table 6.1. Look, situation, look, they are given. Here giving the situations. Look there. A passenger is moving a bus. A passenger sitting on the bus. Number of seats is there in the bus. Passenger are sitting in the bus. And bus is moving. Passenger in moving a bus. The tick mark is given. Okay. With respect to the bus. A passenger with respect to the bus. A passenger with respect to the bus means a passenger sitting. Passenger is not moving. Bus moving. So passenger with respect to the bus what? State of rest. Understood? No? There is a bus. Passenger is sitting. Passenger with respect to bus what? Rest. But bus respect to the road what? Motion. So here who is rest? Passenger is rest. But bus is moving. So there is tick marked what? Passenger with respect to the bus rest. And bus with respect to the road. Bus with respect to the road. That is known as motion. You have to tick mark to the motion. Second option, look. A crow sitting on the cow. You know cow is gazing. Cow gazing, crow sitting. This is the crow, this is cow. Cow is grazing. Crow with respect to cow, rest. Cow with respect to the ground, motion. Tick mark, you have to tick mark. What? Crow sitting on a cow grazing in the field. With respect to the cow. With respect to the cow. What? Crow with respect to cow. Crow with respect to the cow. Yes, what? Rest. Who is moving? Cow. Tick mark to rest. Crow or cow with respect to the ground. Tick mark to the state of motion, moving. Let's look. A child is standing in the field, or on a field is there. Child standing. Only child standing. Child with respect to the ground. Yes, good. Rest. Child not moving. No. So child with respect to the ground. There is asking, no? Child with respect to the ground. We have to tick mark, rest. Child with respect to the sun. Morning sun in the east, evening west. When he looking the sun, time to time it is moves. So child with respect to the ground, rest is standing only. But child with respect to the sun, what? Motion. Understood? Next look. A book on the rotating table. Rotating table. Table respect to the ground, what? Motion. But book respect to the table, rest. Table is moving. So, a book on the rotation respect to book respect to table, rest. Book respect to the table. Table respect to the ground, motion. Okay. Now look figure 6.1. One field. In a field, a cow is what? Grazing. Grazing means what? Grazing. Eating the grasses. Here cow respect to the ground, motion, moving, cow moving. Second one, a boy looking the sun. Boy means a child. Child respect to the ground is rest, but child respect to the sun is motion. Now look at that box. Reference body is the object with respect to which is the state of rest or motion of object is described. Reference body. Crow on the cow. Crow is the what? Reference body. Passenger on the bus. Passenger is respected body. Which one's respect we talking? That is respected body. Child on the field. Child is respected body. Understood? No? Respected body is we are respected, which is we are comparing. Okay. Next, page number 77. There is one figure given 6.2. There is, north, south, east, west. There is mark. There is mark. There, what given now? Here, the path through which person traveling is office, return home are depicted in the figure 6.2. A person is going to office. Different ways there. The travel is office and return home are depicted. He took the road near the hospital to go to office. Look, this is house. This is house. This is house. It is office. It is office. It is house. It is office. Here one more is there. It is the hospital. This is the ration shop. It's a shop. A person going to office through the hospital. A person moving this way and going to the office. This is office. This is house. And he coming back through the shop. Ration depot. Here look. Ear mark. From ear to ear mark 600 meter. From ear to ear mark 300 meter. And ear to ear marked 660 meter, here to ear marked 420 meter, and straight marked here 480 meter. Moving, coming back. I can tell you, a person going to office. Morning event through the hospital and reached the office. When he returned back now, he came back from the ration shop road. Here look distance. He moving from house to office through which way? Hospital. Here to here 600, here to here 300. 900 meter he took morning. When he going to the office, 900. Means here, this road he took. In coming back, he came back from the ration shop. Means 660, 420. Here 1080 meter took. More long he came back. Return back, it took long distance. This is known as distance. But here look, if he moving straight, example, there is not road. I think no road means. But here to here, directly going, if it is a road, straight means there is only how many meter? 480 meter. Here straight is known as what? No. Displacement. And cursive moving, that is known as distance. That is only different. Distance and displacement. Distance is the length of the path he travelled. Length. Which length? It may be cursive. Anyway, cursive way, curve road. How much length he travelled? That is known as distance. But displacement what? Page number 6.2 is there. Displacement is the straight line, okay? Straight, not a cursive. Displacement is the straight line distance from initial position to final position. Initial position to final position, straight moving. That is known as what? No, displacement. Displacement is the straight line distance from the initial position to final position. It has both magnitude and direction. It has the direction. Magnitude means straight, not a curving. Magnitude. Its unit is meter. Example, look here. Just look the example. This is the ground. Throwing the stone. This is the stone. Stone is thrown. Here to here took 7 meter. 7 meter is travelled up. And it is written back. There are also 7 meter. Here distance what? A stone thrown upward and coming back. What is the distance? 14 meter. Moving up and coming back. 14 meter. What is the displacement from ground to topmost? Ground to topmost displacement how much meter? 7 meter. What is the displacement from top to bottom? That also 7 meter. What is the total distance from ground to top to ground? 0. Why 0? Here magnitude is changed. It is moving up and return back. I told no displacement only straight line. It is not a straight. Moving straight and coming back. No. That is direction changed. So distance is okay. Distance is 14 meter. Total distance is 14 meter. But displacement here 0. Why? Because when it is moving up, direction changed. But in distance, direction not. How much distance traveled total? Understood, no? Distance is 7 meter, 14 meter. But displacement is 0. Why 0? Because it is direction changed. But distance, no direction looking. But displacement, direction is important. Upward positive direction, downwards negative direction. So displacement is 0. Look at the page number 77. What is asking question? Look. First look. Distance is the length of the path travelled. How much path travelled? That is known as distance. First question. What is the distance travelled by him to reach the office? Reach the office. From home to reach the office. How much? Right answer 900 meter. Second. Are the distance travelled in the both situations equal? Means you travel to the hospital and coming back to the ration shop. Are this equal? No. Find the straight line distance from home to office. Write it down. Straight line. Straight line. How much? 480 meters. Straight line. That is known as a displacement. Will he reaching the office? If it travels 480 meters towards the north, Will he reach the office? Will he reach the office if he travel 480 meters towards the north? A person in a home, he traveling 480 meters east means reaching. When he is standing at the east side, he moving means 480 meters moving means he will reach the office. When he traveling north side 480 meters, north means this side, 480 meters, will he reach the office? No, it is moving another direction. But he traveling to the east side 480 meters, he will be reach the office. If he will reach to the office when he moving 480 meters north side? No, it is moving other side. Understood? When he moves east side 480 meters, he will reach to office straightly. When he is moving 480 north side, will he reach to office? No, it is another direction now. Office in the east direction. Understood? No answer. In which direction should he travel to 480 meters to reach the office? So, in which direction he have to move to 480 meters to reach the office? Which side? Answer, east side. East side he reaching from home to office 480 meters, he will be reach. North will can't, south can't, west also can't. Next look, the 480 meter straight line distance from the home to the office eastward is displacement. Straight line moving means displacement. What is displacement? Look next one question. What is the total distance covered by him if he traveled from home to office and back to home? Total distance. You have to hear how much? 900 plus 1080. 1980 total distance he traveled. This much meter he traveled. That answer right. Displacement is, that is right, and take in the note, okay. Displacement is the straight line distance from the initial position to the final position. Initial position to final position straight line, that is known as what? Displacement. It has both magnitude and direction. It has the direction, but distance not having the direction, displacement having the direction. Just to look one table given. I told one example. A stone thrown vertically up. One stone is throwing upward. And it is traveling 6 meters. 6 meters. And coming back also how much meter? 6 meters. Question look. When the stone reaching the topmost position, this is the topmost position, how much distance? 6 meters. Complete that. 6 meters. Here 6 meters. What is the displacement? 6 meters. Because straight, no? Distance also 6. When the stone fall back in the hand, stone back to the hand means moving up, coming back total. Moving up 6 meters, coming back 6 meters. So how many distance? 12 meters. What about displacement? 0. Because it is moving up and direction changed. Are understood? Okay, this all right in the notebook. Next page take. Look, figure 6.3. 6.3. Reading. Figure 6.3. A child coming to mom and telling, "Alas, is your score 0 today? You took marks today?" "No, Amma. Today my teacher taught me displacement. Displacement teacher. See, this is the displacement that occurred to me when I went to school and coming back." Correct, no? I went to home today morning from my home to school and school to come back to the home. I went to my school straightly and coming back also straightly. But here direction changed, mom. So displacement 0. When I finding the distance, we have to calculate how much distance traveled. But displacement is 0. So child telling to the mother. Today my teacher teached what is displacement. Displacement is nothing but displacement means distance from initial position to final, not a final to again initial. Moving on straightly. Initial to final and final to initial means their direction changing. That time no displacement is 0. Understood? Understood from the figure? Understood? Okay. Then look on box. While stating the displacement, it is necessary to indicate the direction along with the magnitude of the distance traveled. Here, magnitude and direction looking in displacement. Such a physical quantities having the both magnitude and direction are referred the vector quantity telling. Straight to moving, no, that is the vector. But the distance is a scalar. Distance is a scalar. Distance scalar. Displacement vector. Vector means straight. Initial position to final position. Scalar means cursive. Any shape can move. So here distance is scalar. But displacement is vector. Understood now? We'll ask in the examination. What? Distance full column. Distance full column. Scalar. Displacement full column dash. You have to write what? You have to write displacement full column vector. Displacement full column vector. Distance full column scalar. And the displacement full column dash. Dash you have to write what? Yes, vector. Now look, one figure given, figure 6.4 look. Can see? Okay. Here, like this given. Like this. Here A, B, C, D. Here 80 meter, 100 meter, 30 meter, 60 meter, 60 meter. Look, displacement is the vector quantity. Is distance, displacement is the vector quantity. Is distance then the vector or scalar? What is distance? Distance is a scalar. On the basis of information you have to gather, observe the figure 6.4. This is 6.4. A person starting his journey from a person at A, starting journey from and goes to D. Like this, moving, person moving, goes to D. Person goes to D through B. Means like this, moving and reaching D. A person started his journey from A to and moving to where? D. He took like this and like this one and coming back. Not a movement event state. Cursively event. D through B. A person starting his journey from A to goes to D through B and C. And comes back to A. Come back to A. Again telling. But a person starts his journey from A and goes to D through what? B and C. and comes back to A. Like this, coming back. Come back. There is a box is there again telling a person starting his journey from A is target what to moving to D, straightly not moved, even like this went and like this and come D, went to D and coming back to A. First question, change of position of the travel, distance, while reaching B, distance. While reaching B, how much? 60 meter. You have to write 60 meter here. Displacement 60 because straight, no? 60. So here 60, here 60. First answer what? 60, 60. That is what while reaching B. While reaching B. Next, while reaching C, distance C, 60. First we are comparing distance. While reaching D, while reaching B, 60. Correct? And while reaching C, 60 not, how much? 120. Both add this. 120. While reaching D, 60 plus 60, 120, 150. 150. While return to A, returning, return to A, 100. Means only returning, total not asking. Here, while reaching B, 60, reaching C, 60, 60 plus 60, 120. Reaching D, 30, 150. And coming, return back, 100. We are talking about distance here. Distance. Now displacement. Displacement. Reaching to B, 60. And reaching to C, here direction change. 0. Not a straight moving, no. Here went and turn. Displacement 0. While reaching to D, 0. Direction changing. And coming back to return back 0. Return back, return back. From here to here, return back, you know. Here to here and straight to moving, return back. Minus 100. Minus 100. Direction this side. Straight to moving. When a person reaches here and stopping and returning. Means straight to moving, return back. So here 100 distance. But displacement minus 100 means negative direction it comes. Understood? Next, page number 79. Let to observe the two figures showing in the journey person A to C moving. Here how much meter? 60 meter, 40 meter and 80 meter. Here 80 meter. First question. I think this is now enough. Okay, you're getting more. This is right and send. Next class I taking other. Okay.